All right, let's dive in. Today, we're talking about what might just be the single biggest shift in AI since ChatGPT first blew our minds. We're talking about AI agents. This is the next evolution, and it's set to completely change how we use technology.
So, we've all gotten pretty comfortable with AI that can chat, right? You've got your ChatGPTs, your Claudes, your Geminis, and they are amazing at answering questions, writing emails, you name it.
But what if AI could go beyond just talking and actually start doing things? I mean, what if it could handle complex, multi-step jobs all on its own, acting like your own personal software engineer, or a research analyst, or even a travel agent who actually books the flights for you?
Well, that leap from just talking to actually acting is the core idea behind what AI pioneer Andrew Ng calls Agentic AI. And his point is clear. This is the one to watch. It's not just another cool feature. It's a totally new way of thinking about AI, as a system that doesn't just wait for your next prompt, but actually takes initiative.
So, what's the secret sauce here? What exactly turns a chatbot into a real agent? Let's break down the key parts that give these systems their agency.
You know, at its core, an agent is really just an autonomous system that's working for you. You can think of it as having three main parts. It's got a brain to reason and plan. It has perception, so it can understand the digital world around it. And, this is key, it can act by using tools to get stuff done.
And what makes these agents so powerful is that they run in a continuous loop. First, they plan, breaking a big goal down into smaller, manageable steps. Then they act on those steps, using tools like a web browser or a code interpreter. After that, they observe what happened. And then comes the magic step. They reflect. They literally critique their own work and refine the plan for the next go-round. It's this cycle of reasoning and self-correction that really sets them apart.
Now, this didn't just appear out of thin air. It's really the result of decades of AI research stacking on top of each other. I mean, we started with these really rigid, rule-based systems, then moved into machine learning, had the whole deep learning revolution, and then boom, generative AI, powered by transformer models. Every single step was a building block that led us here, to this new era of autonomous agents.
Okay, this brings us to a really fascinating fork in the road for anyone building these things. When you're designing an agentic system, what's better? Do you build one single, brilliant solo specialist that can do everything? Or do you build a whole team of specialists that have to work together?
And this is a huge debate right now. On one side, you've got the multi-agent approach. The idea is you create a whole crew of specialized agents, maybe a researcher, a coder, a writer, even a critic, and they collaborate. It's modular, you can do a lot of work in parallel. But on the other side, some people argue for just a single, super powerful agent. The thinking is that it maintains perfect context, you don't have to worry about miscommunication between agents, and honestly, it's just simpler to manage and fix when things go wrong.
Now, the data we're seeing seems to give a big edge to the team approach. Check this out. In a study Anthropic did internally, they found that on complex research tasks, a multi-agent system absolutely crushed a top-of-the-line single agent. We're talking by over 90%. And the reason is pretty simple. The team could just divide and conquer, letting them throw more brainpower at the problem in parallel.
However, and this is a big however, the solo agent camp has a really strong counterpoint. The team that built Devin, probably the most famous coding agent out there, argues the exact opposite. They believe that right now multi-agent systems are just too fragile. The agents have a hard time sharing context, so decisions get scattered and the whole thing becomes unreliable.
So, if a team of agents can be both way more powerful, but also way more fragile, how do you actually make it work? How do you get the best of both worlds? Well, the answer seems to be a concept called orchestration.
Orchestration basically means you add a leader to the team. You can call it a supervisor, an orchestrator, whatever you want. This lead agent doesn't actually do the hands-on work. Instead, it acts like a really good project manager. It figures out the high-level plan, delegates tasks to the specialist agents who are best for the job, and then makes sure the final product is a single, coherent thing.
So, a typical workflow might look something like this. The supervisor agent gets a request, let's say, to analyze a company's stock performance. It'll delegate the internet research to a web surfer agent and hand off the data analysis to a code writer agent. Then, once they've both done their part, the supervisor takes their outputs, puts it all together, and creates the final report. This kind of hierarchy is proving to be a really effective pattern.
And to actually build these teams, developers aren't starting from scratch. They're using some really powerful open source frameworks. For example, Crew AI is awesome for setting up agents with specific roles, like a senior researcher. LangGraph gives you really precise control over the workflow, almost like drawing a flowchart for the agents to follow. And then there's Microsoft's AutoGen, which is great for creating flexible agents that can kind of chat amongst themselves to solve problems.
Okay, so we have these powerful, well-managed teams of agents. But right now, they mostly live inside their own little worlds. What happens when we want an agent built by, say, Google to collaborate with an agent built by Salesforce? Well, that is the next big frontier.
You see, the risk we're facing is creating a world of AI agent silos, little walled gardens where an agent from one company literally can't talk to an agent from another. And to really unlock the full potential here, a global network of agents working together, they all need to be able to speak the same language.
A solution is starting to take shape, and it comes in two parts. First up is the Model Context Protocol, or MCP. Honestly, the best way to think about this is like a USB-C port, but for AI. It's a standard plug that lets any agent connect to any tool or any data source securely, no matter who built it.
And building right on top of that is the agent-to-agent or A2A protocol. If MCP is the plug, then A2A is the handshake between the agents themselves. It's the standard that lets an agent from, say, Atlassian actually talk to an agent from Workday, letting them coordinate tasks and work together on really complex business workflows.
And the scale of what this unlocks is just massive. The global AI outsourcing market, which is basically companies delegating tasks to AI services, is projected to be worth over $1.3 trillion by 2030. And universal standards like A2A and MCP, well, they're the plumbing that's going to make that whole market possible.
So what this is all really pointing to is a new kind of internet, a fundamental shift from an internet of websites and APIs to an internet of agents. And that leaves us with a pretty wild final thought. As these agents get better and better at collaborating, what role will they actually play in our lives? Are they going to be our ultimate assistants, our new digital colleagues? Or will they become the invisible, intelligent infrastructure that just runs the world? One thing is for sure, the age of agents is just getting started.